Hi, this video will show you example 3 of chapter 11 on spring mass system. In this example, a mass of 500 grams is suspended from a spring of stiffness 100 Newton per meter. The mass is pulled down 20 cm below its equilibrium position and released from rest. A periodic force Ft equal to 3 cosine t is simultaneously applied to the mass. Assume that the damping force is negligible. Determine the position and the velocity of the mass 3 seconds after it is released. I have a picture of the diagram of the spring mass system at the equilibrium position where the tension and the weight are balanced. Now, this spring mass system is disturbed by pulling down 20 cm below the equilibrium position and external force acting on the mass, and it is released from rest. So all this information are given there, and the tension in the spring with the stiffness 100 Newton meter per meter is also given. So let's look at how do we set up the equation of motion. Now, equation of motion you must memorize is m times d2x dt squared plus c times dx dt plus kx plus ft, where c times dx dt is the air resistance, kx is the tension inside the spring, ft is external force. So m is 500 grams, which is 0.5 kg. C is equal to 0 because there is no air resistance now. The damping is 0. K is 100 Newton per meter. External force is 3 cosine t. So, together with the initial condition, when t equals 0, the position is 0.2 meter, and when t equals 0, velocity is 0. So this is the equation together with the initial condition. Notice that I have divided both sides of the equation by 0.5. So you have d2x dt squared plus 200x equal to 6 cosine t with beginning initial position 0.2 and initial velocity is 0. How do you solve this differential equation? Usually we can use Laplace transform. So taking Laplace transform both sides of the equation, we have Laplace transform of d2x dt squared plus 200 Laplace transform of x equal to 6 Laplace transform of cosine t. Apply the formula card on page 4. You have first term, Laplace transform of d2x dt squared is x squared Laplace transform of x minus x 0 minus x prime 0. Second term, just 200 times Laplace transform of x. On the right hand side, Laplace transform of cosine t is s over s squared plus 1. Now we put in the condition. Initial position is 0.2. Initial velocity is 0. Then you have s squared times Laplace transform of x minus 0.2s plus 200 Laplace transform of x equal to 6s s squared plus 1. Rearrange them, 0.2s, put it on the right hand side. So you move 0.2s to right hand side now. That is how. And then to group the Laplace transform of x here. So eventually, divide both sides by s squared plus 200. You get Laplace transform of x equal to 6s over s squared plus 1 over s squared plus 200 plus 0.2s over s squared plus 200. Now, how do you find x now? You have to get the inverse Laplace transform. Before you do that, you have to do partial fraction. Okay, so what I'm going to do is you apply partial fraction to 6s over s squared plus 1 and s squared plus 200 there, where leave 0.2s s squared plus 200 alone there. Later on, then we combine. So what I have here is actually a partial fraction of this thing to here. Right? So this is as plus b over s squared plus 1 plus cs plus d over s squared plus 200. We're going to find out what is a, b, c, d. Alright, so how to find a, b, c, d? So 6s must equal to as plus b times s squared plus 200 plus cs plus d times s squared plus 1. I'm going to do compare coefficient. First, let's compare s cubed first. On the left hand side, there is no s cubed. On the right hand side, I have as times s squared. We have as cubed. cs times s squared, I got cs cubed. This is the first equation. On then the second equation, I compare s squared now. Left hand side, no s squared. Right hand side, I have b times s squared. And then d times s squared. This is the second equation. For the third equation, I compare s now. The left hand side is 6 now. The right hand side is 200 as indicated by green arrow and cs. This is the third equation. Finally, the fourth equation, compare constant. Left hand side is 0. Right hand side is 200b plus d, indicated by the orange arrow. So we have four equations, four unknown. Now, from these four equations, four unknown, you look at the second equation and the fourth equation. Both of them, b plus d equals 0 and 200b plus d equals 0. This will give you both b and d equals 0. So you actually have to solve the first and third equation only, which you have c equal to minus a from the first equation, then substitute into third equation. Right? So c equal to minus a, substitute into the third equation. So 6 equal to 200a plus minus a. You get 199a equal to 6. So a is equal to 6 over 199. And so c is minus a. C equal to minus 6 over 199. And b and d are 0. So I put in the a B, C, D, where B and D are 0, and you have Laplace transform of x equal to 6 over 199s over s squared plus 1 minus 6 over 199s over s squared plus 200 plus 0.2s over s squared plus 200. Now the last two terms can be combined. The last two terms can be combined because they have a common denominator, and you get 0.0302 s over s squared plus 1 and 0.1698 s over s squared plus 200. So x, in this case, you take inverse Laplace transform now, is equal to 0.0302 cosine t plus 0.1698 cosine square root of 200t. So this will give you the position of the mass at any time. The question asks you, what is the position of the mass at 3 seconds? So when t equal to 3, you substitute t equal to 3 into the expression for x. Now make sure that your calculator is in radian mode, and you'll find that the x eventually is equal to negative 0.027 meter or 2.7 cm. And because x is negative, the position of the mass is above equivalent position. Okay, because x is negative here, therefore this position is above the equivalent position. Then they also ask you for the velocity. How do you find the velocity? You differentiate the position. So you look at the position again, then your differentiation. So remember, differentiate cosine t, you get negative sine t. Okay, differentiate cosine square root 200 t is minus square root 200 sine square root 200 t. Now put t equal to 3. Again, make sure your calculator is in radian mode, yeah? And then you find that your dx dt is minus 2.405 meter per second. What does it mean? Since dx dt is negative, so the value of x is decreasing. If a value of x is decreasing, means the mass is moving upwards. So here we have completely solved the example.